know it's crazy, but it's
You're watching Channel Z, the world's leading zombie apocalypse channel. Broadcasting live from Studio Z.
Makes me act the way I do.
Welcome to Eat, Pray, Run, where slow food in the apocalypse doesn't mean you're going to end up on the menu. I hope you brought your appetites today. I'm Dr. Erica O'Neill, and today we're getting a little crunchy, a little hippie. We're embracing our fermenting roots, and we're talking Booch. So you might have seen kombucha bubbling away in the health food aisle, but there's so much more to it than just a refreshing beverage. We're going to talk about cooperation, the microbiome, and how this fermenting beverage is really a great model organism for studying that. But first, a quick word as the originator of the cult of caring. When the chaos of the day gets a little too emotionally taxing and the psychedelics are all used up, we've got 3 hots and a cot waiting for you at the cult of caring, whether you're undead, recently deceased, or fully alive. And thank you, Dr. Greg, yesterday on this program for telling us that omega-3s are a very vital part of brain nutrition. We are happy to feed any of our undead compatriots. We have plenty of those omega-3 fatty acids to calm your inflammatory cascade. Because while snacks are the opiates of the slightly hungry, sharing food with others is a fundamental aspect of what makes us human and brings us together as a community. So consider joining the cult of caring. But enough politicking. And in the spirit of sharing food, we have a kombucha expert and cooperation scientist with us today to offer some metaphorical fresh brains for your consumption. Let me bring on the kombucha queen, Gissel Marquez Alcaraz, to the show. I see that you've branded yourself well for the occasion. It's fantastic. Kombucha queen. So you've got some for us to sample today, but if I understand it correctly, usually you're using this as like a research opportunity instead of a way to supplement your own microbiotic health.
Yeah, so I see kombucha as like a aquarium of yeast and bacteria that I study, and I study the cooperation between the yeast and the bacteria and essentially how they interact, so to keep the kombucha alive, fed, and full of resources.
That's fantastic. I want to learn a lot more about that. And we have a graphic that illustrates that pretty well, about what kombucha and the cooperative aspects of these different organisms are doing. So if we can pop that up really quick, maybe you can walk us through this. Like what is actually happening in this beverage?
Okay, so I drew that figure, so I'm super excited that we're showing this figure.
Nice.
Essentially what kombucha is, it's a fermented black tea beverage. It has 4 components. It has tea, sugar, and then the 2 live components, which are yeast and bacteria. Mm-hmm. When you have an existing kombucha like the one we have on our table, you're going to want to feed it with tea and sugar. The yeast is going to take that sugar, break it down into glucose and fructose to then be eaten up by the bacteria. Then the yeast and bacteria are going to produce byproducts such as the cellulose or SCOBY, which is what grows on top of the kombucha, as well as gluconic acid and acetic acid, also ethanol, which give it its antimicrobial properties, and also that CO2 to make it a little bit fizzy.
Nice. So the ethanol is what makes some kombucha hard kombucha, right? If you let it ferment a little bit too long, the ethanol level rises and you have an alcoholic beverage by then, right?
Yeah, actually, a lot of the store kombucha bottles, they'll have a expiration date on the bottle. It's not because the kombucha goes bad, it's because the alcohol content goes up, and at that point you're not drinking something that's not going to make you a little buzzed. So
gotcha. Yeah. It's good to have that warning then. So let's talk a little bit about how you do use this in the lab. So this one you have created for us to try a little bit further on in the show, but usually you're just growing these for experimental purposes.
Yeah, so in the lab we have a kombucha culture that I've been keeping alive for 4 years. And so I feed it every 10 to 14 days, and I also run different experiments on it. Essentially just observing I like to think of it as like a little colony of microbes, but essentially just observe the colony, see how it grows, see if it can ferment properly under different conditions. But to me, it's just something I study more than something I drink.
But it is like a pet. You're feeding it. You're doing that on a regular basis.
Yeah, it's like a little aquarium with all the little things swimming in there, and I gotta feed it.
A model organism, but instead of being like a little mouse, you've got just this lovely little thing here. Let's see if you can tell us a bit about what's in here. So where's that SCOBY that you talked about, and what is a SCOBY?
So the SCOBY, it floated to the bottom because while I was transporting it, it got shaken a little bit, and then it went to the bottom. But usually it's at the top. If I was to feed this, another layer would grow at the top. And essentially what that is, it has like a very skin-like texture. And it's a biofilm that grows on top of the kombucha. It prevents different microbes from coming in and possibly invading the system. It also slows down evaporation. And we have hypothesized that it's a way for the microorganisms inside of kombucha to preserve excess resources.
All right. Well, let's get into some of those experiments.
Okay.
Did you want to start with the open door experiments? What does that mean?
So Open Door is an event at ASU, and essentially what we did is we wanted to test kombucha's antimicrobial properties. So what we did is in one jar we had just normal black tea, and in another jar we had kombucha. We had participants come in and we swabbed up their hands, a total of 30 swabs, and we put half of the swabs in kombucha and half of the swabs of the tea in the tea. Then after 30 days, we saw that the tea, which is the one on the left, it became totally invaded by mold, different types of bacteria, different types of yeast, while in the kombucha stayed completely intact. It grew proper SCOBY, the color looked normal. When we did the analysis, there was some new bacteria in there, but nothing major. Overall, the contents and the diversity stayed the same.
That's fascinating. So it's acting like a filter.
Yeah.
To keep the overall kind of colony aligned and in good health.
Yeah, and it's not just the SCOBY that does that. It's a lot of it has to do with that acetic acid, gluconic acid, and the ethanol as well, which help get rid of those bad microbes and stuff.
So is that so in addition to the ethanol, which can act as kind of a disinfectant in itself, are the others like a pH that's more acidic to keep things kind of
So yeah,
check?
Yeah, so that contributes to the pH of the kombucha. Kombucha is actually really acidic. We tend to keep it between 2.5 and 3.5 pH. But yeah, definitely that low pH is going to be what helps keep it clean.
Gotcha. I saw a comment from Dave. Dave, as a member of the Cult of Chaos, I encourage you to do whatever you'd like with that moldy tea. Personal choice is one of the founding tenets of your cult, so you go for it and report back on what the results were. I'll stick with the kombucha, though, because I like that it filters that out and kind of keeps things in check. So I know that I'm getting something that is optimal for the microbiome that it's trying to host and then also is compatible with my own.
Yeah, definitely. And then we see how, I think that if kombucha can do such a great job of keeping out that bad bacteria within itself, imagine what it can do inside our guts when we're consuming it regularly.
All right. So you have a couple other experiments that you've been up to, kind of testing the resilience of the SCOBY and the cooperative aspects of how it's working in sync with everything there. Yeah. Talk a bit about this kombucha invasion that you've got going on here. What's this image?
So when you make kombucha, you want to make sure that you have 20% starter. Essentially what that means is you want to have a little bit of kombucha from already existing kombucha colony. And what that 20% means is that if you're trying to make 1,000 milliliters, you're going to need 200 of starter, so old kombucha, and then 800 milliliters of freshly brewed black tea. We wanted to see if we can lower the amount of starter from anywhere between 0 to 8%. And so we did an experiment trying that, but what we saw is that some of our samples became invaded. After we saw that they became invaded, I kind of still let them run to see what would happen.
That's science.
Yeah.
You just got to let it run.
Yeah,
the observations.
Yeah, and so I did. And what I ended up seeing was that the invaded samples grew SCOBY that was way bigger than the non-invaded samples.
Really?
And the super interesting thing was that the SCOBY grew as if kind of to engulf the invasion, what appeared to be an attempt at keeping it away from the rest of the liquid. So we've hypothesized that could be kind of like a kombucha immune system taking place.
So the rest of the liquid is like the food source too. So it's trying to protect the resources that it has available to make sure that nothing infiltrates that.
Yeah, exactly. Because the precious resources that's inside of the kombucha is going to be the sugar, because that's what overall feeds the cycle. It feeds the bacteria, which then feeds the yeast, or it feeds the yeast, which then feeds the bacteria. And so I believe that it's probably doing that to protect that precious resource that is sugar.
So you broke this down. So you just gave us an overview of it, but you
Yeah.
broke it down in a pretty systematic way. So what was the first experiment one that you ran?
So experiment 1 was just to see if we could lower the amount of starter. And this is what ended up happening. The SCOBY at the top, those are from invaded kombuchas. And as you can see, that invasion is inside of the SCOBY. And
so
those
are the ones at the bottom also tiny little scobies? Or
those
they...
are those tiny little SCOBYs are
Okay.
from normal kombucha.
Gotcha.
From kombucha that wasn't
It
invaded.
didn't need to amplify itself in order to deal with the invasion.
Exactly. And so it remained pretty normal, about 2 grams for the non-invaded kombuchas, where the invaded kombuchas, they were growing SCOBY up to 23 grams. So it was a huge difference.
That is a huge difference, especially since you're doing these in small beakers and you don't have like a half gallon of SCOBY, or a half gallon of kombucha for the SCOBY to grow in like we have in front of us today.
Exactly.
So what about experiment number 2? What do we got going on here?
So
some more kind of gross looking things. So walk us through it. It's the apocalypse. We can handle a little gross.
All right. So experiment number 2, I essentially did the same thing, except I let all of the samples get invaded. What I ended up seeing is that the higher amount of kombucha starter that we would add at the beginning of fermentation, the more successful the SCOBY was in engulfing the invasion. So for example, 2% kombucha starter didn't produce any SCOBY. Nothing got engulfed in the invasion, remained persistent. And 4% SCOBY, it engulfed about half, a little bit more when there was 6% kombucha starter, and then it was able to engulf the entire thing under 8% kombucha starter conditions.
Okay, so what is the starter doing in this aspect? Is it like training the rest of the system to recognize like pathogens? Like the more you have in there, the better it is at doing that? Or what is the starter up to?
So, without the starter, we would just have normal black tea. The starter serves the purpose of introducing that microbial community into the tea so then it can then thrive. So you're adding yeast, you're adding the bacteria, and from there on, they do pretty much all the work, taking care of that sugar, processing it the way they need to, and then creating the byproducts like the SCOBY, acetic acid, gluconic acid, etc.
Yeah. It seems like the more cooperative elements you introduce, though, the more little cooperative critters go in there at the beginning, the better off the overall cooperative schema is, though.
That's true. Kind of like a safety in numbers kind of thing.
There you go.
Yeah.
All right, let's move on to our next experiment. We have experiment number 2. Or is this 3? Experiment number 3. We just ran through 2.
So
this is also kind of gross looking here.
Yeah.
Sorry, everyone. Scobies, they're inherently like a little slimy and gross. So it's just life.
It is, but it's not bad. I've been working with it for a while now, so handling it isn't super bad. So experiment 3, I essentially did the same thing. And what I ended up seeing was these biofilm overgrowths. You can kind of see it in the jar. It's kind of like a SCOBY pimple in a way.
That's what it looks like.
Yeah. So what we thought these might be small localized invasions that might have been taken care of by the SCOBY. We're not exactly sure what it is, but just based on the results from the previous experiments, that's what we think it might be, just tiny invasions that the system can take care of super quickly with a little bit of SCOBY overproduction. And then we're good to go.
Well, this is a wonderful example of caring and cooperation. Even though it looks chaotic, it's just because you don't know the systems going on behind the scenes and how they're feeding into one another.
Yeah, that's totally true. A lot of people don't like kombucha or they're scared of it because of the live component. But really, it's a really nice cooperative system. So you shouldn't be afraid of it. It's all peace and love in here.
That's fantastic. So do you want to try a little bit of this peace and love, and then we can chat a bit about kombucha? The SCOBY?
Yes, I do, because I understand that you like to brew kombucha at home to drink.
Yeah, I got a nice big, like it's a big old ceramic vat that I use.
Really?
Nice and dark in there.
Oh, okay. See, I make it in the lab. And I make sure that the pH is correct. I make sure that I'm adding the proper amount of sugar and everything, but I'm not allowed to taste it in the lab,
All right.
And so I want you to tell me
if this is the first run.
Yeah, if my kombucha making skills are like good to drink or if I should just stick to the lab.
Stick to the research?
Yeah.
All right, let's give it a whirl.
So I'll serve you a little bit.
Oh, I'm seeing some bubbles. It's got some little fermentation there. That's good. That's what we're looking for.
I mean, it grew the SCOBY pretty nicely,
It did. That's a nice thick SCOBY. You can see it really well on the camera here at the bottom.
Yeah, you can see it. And like I said, it would usually grow at the top, but it kind of floated to the bottom. All right, cheers.
Cheers. You know what? All you need to do is add a little simple syrup and some crushed fruit. You have flavored kombucha and you're good to go.
I agree. It's not terrible. It's
not terrible.
Yeah.
Starling review.
Yeah.
It's not terrible.
It's not like straight up apple cider vinegar.
Yeah.
You know?
Some of them, if you let them go too long, they get really acidic. So you could have just pulled it a couple days earlier too. And that's like the trial and error of trying to figure out what you're doing with Booch when you're brewing it in your house. Like, you just try it.
Yeah.
Like as you go, you wait for a certain amount of time, a few days, then like you just like take a little sample. And once it's bubbly enough and it's kind of acidic enough, you can put it into bottles, put it in your fridge, and it'll keep bubbling away to get a little more fermented.
So this needs to be bottled up, you think, too?
So if you put it in there, it stops the acidic production of everything that's happening, but it'll keep fermenting. So you'll get a little bit more. That's just like you said with the goodbye date that they put on there. Like they want to make sure that like the alcohol content doesn't get too high. So drink your Booch in a reasonable amount of time.
Okay. Interesting.
But after you bottle it and you add that stuff to it, you can't really go back to using it as that starter. Like everything in here you could use to make a whole new colony of Booch with just like a little bit of SCOBY.
Really? I didn't know that you couldn't use it as starter anymore after you bottled it.
Well, yeah. I mean, you just put a bunch of weird stuff in there.
That's true.
This is no longer a contained kind of a unit that you can like rely on. I'm sure that in the lab you could add some strawberries and see like what sort of introductions from the bacteria and yeast were included in there. But
yeah, I think it'd be interesting to do like an invasions experiment with some type of fruit in there and seeing how that might affect the experiment. I think that would be awesome.
Experiment number 4.
Yeah, perhaps, huh?
You learned something today. You can take it back to the lab with you.
Yeah, for sure.
So tell me a little bit about the SCOBY. Like, I understand that you've been doing some weird things with it afterwards. Like, it's not just the kombucha that you're looking at. It's also like you're trying things with the SCOBY.
Yeah. So, in the lab, I've been keeping it alive for 4 years. And I realized that I was making a ton of SCOBY.
That is one of the big problems of like brewing kombucha regularly is that it just grows to encompass however big your vessel is. And so it can really get like thick too. And you're brewing a big batch.
Yeah, and it layers and layers and layers, and then you can have like this much SCOBY, and it's like, what do you do with it? You know? I did the math, and I've produced a little bit over 1,000 pounds, I believe, of SCOBY in the lab.
What? That's insane.
No, yeah, it was crazy when I did the math. It was like an approximation, but I thought, like with all the SCOBY, what if we kind of looked into making some kind of material with it? You know what I mean?
Yeah.
So
I've heard of that before too. Like people can dry it out and you can use it as kind of like a makeshift leather type substitute.
Yeah. There's a fashion designer. I believe her name is Suzanne Lee.
Yes.
Yeah.
She makes things with the SCOBY left over.
Yeah. She makes like jackets and all that stuff. It's super cool. But the only problem there is that the SCOBY is really porous and it's really absorbent. And so you put it in water, it's instantly going to turn back into like a biofilm.
Okay. Well, that's a little gross. I don't know if I want to wear that out and about. But here in the desert, it's not that bad. It's pretty dry out. Like the majority of the time, you could get away with wearing SCOBY so long as you're not sweating.
Well, you'd be surprised because I had some SCOBY leathers in the lab. It was humid because of the monsoons. They turned back into SCOBY.
Really?
Yeah. Just drying in the lab. They were dry all of a sudden, and then I came back a few days and.
That's wild.
Yeah, it is.
So what have you been doing in the lab with this 1,000 pounds of SCOBY? Like what have you been up to?
So before I used to throw it away, and then I started feeling bad that I was throwing all this material away. And so we started a project called Kombucha Matter. Essentially just trying to see if we can make some type of material with it or seeing what we can do. We still haven't figured out the whole waterproof part.
One step at a time.
Yeah, one step at a time. But we found that we can embed different things inside of the kombucha to kind of fortify it. So we've added silk,
oh my goodness,
wool, polyester.
Kombucha fashion.
Yeah, and then at the end, that's kind of what a dried SCOBY leather looks like, and it's embedded with the polyester. And so just like the SCOBY would engulf the invasions, it also engulfs these materials and embeds them within. And it actually turns out like a really pretty material, I think.
It's a natural tie-dye.
Yeah, pretty much. That's a really good
You
way
have
of
all
thinking
sorts
about
of
it.
interesting inclusions in different areas that pop.
Yeah.
Well, I've also heard of folks using scobies, drying them out as dog toys, like
No way.
dogs can chew on it. I mean, it's just a symbiotic colony of bacteria and yeast.
That's a great idea because
So you can slice it up, you
Yeah.
can dry it out like little jerky strips. Dogs love it. I mean, dogs will eat anything, but if you're looking for a way to get rid of things that aren't in a research context, like the SCOBY that you just created, that's one option.
Yeah, that's a great idea. And then you can build up your dog's microbiome as well.
There you go.
Have you done that yourself with your dogs?
They have eaten SCOBY before, yes.
Really?
Well, I showed you virtually. I have one that's just like layered upon layered. I just throw all the SCOBYs in there when I'm done with them.
Yeah.
And so that's where I pull it from.
Wow.
Just got a little SCOBY disc.
I'm gonna have to try that. That's incredible.
Give it a whirl.
Yeah,
I don't do it regularly. They prefer meat flavored chews more.
Totally.
if they were given the option. I have not done this, but people have candied SCOBY too, where you like boil it in a sugar syrup for a while and it like gets really infused with that. And then you get the benefits of that microbiome and it's nice and sweet and it's a lot
Really?
easier to eat.
Like a fruit roll up?
Yeah. Like like a candied fruit roll up type thing.
Wow. Okay. What's your favorite thing that you've done with SCOBY or kombucha or anything like that?
I make a new one.
Make a new one?
I too have the problem where I don't know what to do with a ton of SCOBY that gets left over.
Yeah. It's a big problem because like it can keep on growing.
It does.
And just kind of a pro tip for all of you, if you have kombucha at home like this, don't pour it down the sink, because if you pour it down the sink without first killing it with a little bit of bleach, you're going to end up getting a lot of SCOBY growth in your drain, and then that's going to clog up your whole like drain and your sink and all that stuff. So never pour live kombucha down the sink. Make sure you add a little bit of bleach first.
Yeah, if it's been in the fridge for a while, you've kind of like made everything dormant there. You're not going to run into the same issue. But thank you for that pro tip. The biofilm spreads. It's going to do what it's going to do. So long as it can get introduced to a little bit of sugar, it'll go wild.
Yeah, it totally can. It's like a live monster, a live zombie, if you will.
So have you branched out to any other areas of fermentation?
No, I have not. This is the only thing I really play with because it's my work. But I think fermentation is really cool. Fermentation is like an ancient way of preserving food. And then because of fermentation, that's why humans were able to stop having to move around, because before we would have to move around depending on the weather to find food, to hunt animals and stuff like that. But when we found methods of food preservation like fermentation, we were then able to stay in one place, preserve our food, build towns, which then cities, and then evolve into the world that we have now. So fermentation is really cool.
It all started with these humble microbiomes.
Yeah.
So if you do want to try something out, it's really quick and easy. You can make a ginger bug to make like ginger ale.
Okay.
Real similar to this, where you're fermenting it. You don't have to introduce anything outside of organic ginger because you want like the wild beasts on the outside of that ginger. You grate all of that up. You add it to water and sugar. You just let it sit. You can put it exactly like you have in here, just like sitting on a counter to make sure nothing kind of goes in here. That's what the filter's for at the top. And then give it a sip every so often. Once it's tasting good and it's a little bubbly, bottle it up, put it in your fridge. You got to burp it every so often like a baby so that it doesn't like get a little bit too fermented. But yeah, give it a whirl.
No way. So it's just, so you just said ginger, sugar, and water?
Got to be organic because like they irradiate a lot of the stuff that isn't, and that kills everything on the outside.
Wow. And so it ferments the same way as kombucha, like does it produce the alcohol and stuff or no?
So it's the same with kombucha where like if you let it go too long, any process of fermentation creates that as a byproduct.
That's true, yeah.
So you just make sure that you're not letting it go too long if you just want a ginger ale instead of a hard ginger ale.
Yeah. Okay.
Yeah.
Sounds good. Thank you.
Try that out.
I'll definitely try. I know that people like ferment their vegetables and stuff as well.
Oh,
so maybe that's like a great way to prepare for the apocalypse,
Oh, I'm there for it. I'm with you.
Yeah. Ferment your foods, keep them stored, keep them preserved, and then you're good to go in case everything hits the fan.
Yep. And then learn canning. It's really easy to screw canning up, just like it's really easy to screw fermenting up. But both are very good for food preservation in the long term for the apocalypse.
Yeah.
Or just for having to shelter in place for an unforeseen amount of time, which everybody just went through recently.
That's true. And not only do you have food, but you're also keeping your microbiome good.
Keeping healthy. Well, thank you so much for joining me today.
No, thank you so much for having
I appreciate you
me.
bringing your big brains onto the show and for sharing this wonderful Booch.
No, yeah. Thank you for having me. It was good. I'm glad I got feedback on my kombucha making skills. So, maybe I'll continue at home. Try to get as good as you.
We can have a kombucha off.
Okay. Next Zam. I'll see you there.
Next Zam. Sounds good. We'll bring our best.
Yeah, sounds good.
All right. And thank you all at home for joining us. As always, we really appreciate you tuning in today. And until next time, we hope that you stay hungry.
And if the